we're now going to study enumerations, right? This will be a faster set of lectures than the structs because these are declared in a very similar way. So we'll see if we can actually make an enumerated data type. And that includes the definition normally of all possible values for variables of that type, meaning we use these to indicate state a lot of times. Right. So an enumerated type is a data type, as we said, whose all possible values are listed or enumerated by the programmer. Meaning, if we create a type that has 4 possible values, we're going to list all 4 of those values. If we list 3 values, it has 3 possible values. So it won't have values that we don't include in our list. That's what that means. Right? The value name is actually an enumeration constant. Right? It's going to be a constant value. They're subject to C scope rules, depending on where we declare them, depends on where we can use them. Right? We're going to then declare a tag or a typedef, then to create a genuine type name. And it's going to treat all of these enumeration variables and constants as integers. So we're going to then use the keyword enum, right? Keyword enum and then a tag. So in this case, enum, our tag is status. So this defines an enumeration tag named status with 4 states: on, off, maintenance, error. They don't have to be all in caps. A lot of times we code constants in all caps, and that's why I followed this convention. Right, we're going to see when we don't give them values, they're going to have some default values. So once again, enum, keyword enum, and then the tag name was status. And actually, let me just fix this in terms of the fact that I don't like it when this changes things to all caps. Let me pop that back up. All right, so all I did was I put that back in smaller case. My tag name was status, right? PowerPoint had capitalized it for me. And it had then these 4 enumeration constants: on, off, maintenance, or error. Notice they go inside curly brackets, right? And it ends with a semicolon, right? So by default, the compiler is going to assign 0, 1, 2, and so on, and 3. Then to these constant values. So notice here in this list, we didn't give them any value. So it's going to default, the first thing is going to be 0, the next is 1, the next is 2, and the next is 3. If you don't want them to have those values, if you want to specify the values, then when you declare the enumeration, you can go ahead and set them. Here, if I set on equal to 22, and if I assign 0 to off, notice it doesn't have to be in any sort of numeric order. It's whatever I assign these states to. Then whenever I refer to on somewhere in code, it's like referring to 22, right? Whenever we refer to error, we refer to 99. These, like I said, these probably remind you of your pound defines, right? Those are constant integer values as well. And it's easy then for us to use these names in codes. It's easier for humans to read and give meaning to that, right? And now if I want to declare a variable of type enum status, then enum, keyword enum status, so enum in the tag name, and then this is my identifier name device, right? So now if I create a device, its data type is enum status, identifier name device, data type enum status, right? Let's take a look at example 9. That example then is going to define then this enum status, right? On, off, maintenance, error. So 0, 1, and 2, right? And then I'm going to create an array of those. So not only can I create then a single variable or identifier, I can create an array of those. And then to each one in that array, I'm just going to go ahead and assign a state to each one of those values, and we're just simply going to print out the state. So let's take a look at this code. Here's the example 9 code. It's a tag example. All right, so here in main, you can declare these outside main so that they're global to the entire file. Since this program only has one function, I went ahead and declared it inside main. Right. So enum status, right? Keyword and then the tag, on, off, maintenance, error. Then I create this array, right? So device then has 4 elements. Its data type is enum status, right? And then to each one of these, I'm just assigning a state. And what I'm doing now is I'm going to create an array of strings that I'm going to use to print out the state, right? So remember then, these states, this is like assigning 0, 1, 2, and 3. These are the constant values. By default, the compiler gives this a 0, gives off a 1, maintenance a 2, error a 3. But if I want to print out strings to show those states, then we often create an array then. A string is a char star, right? Two-dimensional array, char star, and then I use the empty brackets here, and now we have an array of strings. So state at index 0 is going to be the string on, string at index, so state at index 1 is going to be the string off, state at index 2 is going to be the string maintenance, state at index 3 is going to be the string error. So now if I want to display the enumeration values, here I'm just using some printfs, and here then, because on is an integer, right, we use %d. These enums are integers, so we use %d to show their numeric value. And that's all we'll do here, show the numeric value. Then I'm just going to run through and display the state of each device in terms of its constant value and then its string. So here's my for loop, right? I've got 4 of these. I'm going to print out device at index, so we'll see the index number, right? And then based on that, I'm going to switch on that number. And so when it's on, we'll print out then the string associated with on. When it's off, that string, maintenance, the string. So this is just a way to show you how to make a very simple state machine, right? Normally we want to print, we want to do more than print when we have different states. But this is often how we create a state machine, is that we'll use enums to give these states names. We'll use a switch to then control the behavior of our program based on whatever state we're in. So this is giving you a structure for doing that. Right? That's where we'll commonly use enums. Right? And so I've already built this. I'm just going to go ahead and run it. So when I run it, we get the output. Right? So here's our state values. Remember up here, that's what we're doing right here. We're just simply displaying the fact that these values are these constants, 0, 1, 2, and 3. And now as we run through the states here, device at index 0, that's where this came from, device at index 0, state is, and then so based on the actual state, right, in this first case, it was case on. Well, we go to state, so here's the state array, index 0 prints out the string on. Right, so that's all we did. So like I said, often when you want to print out strings that equate to the states, right, print out that, you'll create a little array that will match the same index. The index values of this will match then the same as your enum constants. So that's just a easy way to make it readable in terms of state. Because if you were to print out state 0, well, if you had several states, the user of the program has a harder time of knowing what 0 is than if you just actually print out the name of the state. So that's a handy method for doing that. All right, and that's the way we do it then, right, with a tag. What we're going to see next, right, is we'll just open up then example 10, which we'll be using typedef. So similar to what we did with structs, we can use the keyword typedef in front of enum, and then we create a type name that goes after our list. So typedef enum, curly brackets, put all your constants in there, right? All your names, all your enums, right? Your enumerated list, and then put the data type name. And then when you're going to use the data type, right, since we've used typedef, you don't have to use that tag name. You just use the name of the data type. Right? And example 10 then will show us then how to do this. Right? So let's pop open example 10. All right. So example 10 is it going to then, we're going to, I'm going to build a, sorry, still running the last one. Let's say build and run, and we'll take a look at it. First, I just want you to see that the output here is going to be exactly the same as before. We're going to show our state values, these constants, and then we're going to show the strings representing the state. So the output from example 9 to example 10 is no different. The only difference is here, when we created our enumeration list, we said typedef enum. Right? Our enumeration list is still the same. Then here's our data type names. Status went here. Our state array is still the same. I've actually got a function here to print this, but let's go to main. All right, so we still created then an array then of 4 enums of type status. Right? Before, when we use the enum status tag, we had to use the enum keyword here. When we do the typedef, we then, that keyword goes away when we use it. So we say devices of type status, there's 4 of them. And just like the previous program, we just assign each one of these a state. Right? And here we're just going to print out the enumeration values. And then here, right, instead of using that switch structure, all I did here was use the for loop to go through then and print out the state. So I could show you then how to use these inside a function. So all I'm going to do is pass device at index I to a function that prints out the status description. So here's my function, right, print status description. Well, I'm just going to pass it a copy of the enum, right? Here it's of type status. I'm going to refer to it by device, and here is our state machine, right, based on our switch. So it looks like my state machine. My switch is still here, right? In each of these cases, we just print out the string. So this was very similar to example 9, except we used typedef and enum. Our data type became status, so we didn't use that tag, right? And we don't need to use the tag there. If here we were to switch this from typedef back to enum, right? And then say status, put the tag there, right? Get rid of the type name here. Now I have to change this to enum here, status. Same way here, I have to change this to enum status. And if we build and run, we get the same output as the previous program. Right? So those are the differences then. Right? With typedef, we don't use the keyword enum. Right? Here, we use type definition, typedef, and then we give our type name. That's what goes here is our type name, and I could leave some space there to make that readable. And those are the differences between the two. Once again, let me rebuild that to make sure I didn't change anything. No. Right. And so that's it for enums. You're going to commonly use those then when you want to create some sort of constant, right? Notice we said, the lecture note said we list all possible values. So this particular enum has 4 possible values, doesn't it? 0, 1, 2, and 3. And we often use the default values. Like I said, if you're working with a piece of hardware where you have something in the data sheet that says the off state or the maintenance state is represented perhaps by the constant, and it can be negative, right? Maybe -3 is your state. You can then go ahead and set up that information. So they can be integers, excuse me, positive or negative. All right. And they do often come in handy when you're working with programming hardware, programming state machines, right? Whenever you're going to run software with hardware, you almost always have a state machine. Right, so that's it for our enum topic.